In today's notes, we are going to be learning about isosceles triangles, which is something you learned back in 7th and 8th grade. So isosceles properties, they have two equal angles and two equal sides. And we'll call the angles the base angles. So you'll see in this diagram, these two angles are congruent, and the two sides that are adjacent to the angle are also congruent. So now we're going to solve a few problems that rely on us using this information. But first we're just going to focus on a regular triangle. If I wanted to figure out the third degree of this triangle, I would have to add the two other degrees and subtract them from 180, because I know that in total a triangle always has 180 degrees. So we would take 180 and subtract 58 and subtract 47. So if we had 180 minus 58 minus 47, that gives us 75. So that means that our third angle is 75 degrees. In the second problem, we're looking at a right triangle, and instead of having numbers, we have expressions where there are angles. So in this case, if we wanted to figure out what x was, x is in this expression and in this expression. An expression it represents a value, but we don't know what the value is. So instead of just subtracting from 180, we're going to have to add up our three sides and set them equal to 180. That would look like 2x minus 2 plus x plus 5. So 2x minus 2 plus x plus 5 plus, we know that that means 90, equals 180. And now we can use inverse operations to solve. 2x plus x would give us 3x. Negative 2 plus 5 would give us 3. 3 plus 90 would give us 93. And then we'd bring down equals 180. We would subtract 93, and that would give us 87. When we divide by 3, 3 goes into 87. (29 times). So we know that x equals 29 degrees. But if we wanted to figure out what the actual degree measure was, we'd have to plug 29 back in. So for this one, 29 plus 5 would give us 34 degrees. So this angle is 34 degrees. This angle is 90 degrees. We could use 34 plus 90, subtract 180 to figure this out, or plug in 29 into the expression. It doesn't matter. I'm just going to subtract from 180. So we have 180 take away 34, take away 90 gives us 56. So we know that that angle is 56 degrees. We're now going to use properties of isosceles triangles to help us solve for missing angles. So I know that this is an isosceles triangle because it has two congruent sides, and I can see that by the labeling with the little hash marks on two of the sides. Now, we know that with isosceles triangles, they have two congruent base angles and two congruent sides. Therefore, if this is 50 degrees, this is also 50 degrees. So we just figured out one of the missing angles. Now, if these two are 50 degrees, then the third angle has to be 80 degrees. Because 50 and 50 give us 100. 100 plus 80 gives us 180, and we know that a triangle has 180 degrees. For the second problem, again, we know it's an isosceles triangle because it has two congruent sides, and the two base angles are congruent. But in this case, we're not given a base angle. We're given the top angle that's not congruent to anything else. So in this case, I'm going to have to think, okay, if there's 180 degrees in a triangle, and this one is 40 degrees, that means we have 140 degrees left that we have to split evenly between these two angles. Which means they both, if they have to be congruent, because it's an isosceles triangle, the only number that would add up to 140 if added twice is 70 degrees. So we know that x is 70 degrees and y is also 70 degrees, because 70 plus 70 is 140, and they have to be the same number because they're isosceles. In our fifth example, we're going to use an expression, a 90-degree angle, and again, we know that these are isosceles triangles because there are two congruent sides. So because this base angle needs to be congruent to this base angle, we can label it as 2x plus 3 as well. So just like in this one where we couldn't subtract, we had to set up an equation, solve for x, and then plug x back in, we're going to do the same thing for this one. We're going to take 2x plus 3 and add it to itself twice for each of the base angles, plus 90 degrees for the right angle, set equal to 180 because there's 180 degrees in a triangle. 2x plus 2x is 4x, 3 plus 3 is 6, 6 plus 90 is 96 equals 180. Subtract 96, and we are left with 4x equals 84. Divide 84, that goes into 8 two times, so x equals 21. So we know that x equals 21, but what do these base angles equal? To figure that out, we're going to plug 21 back in. So if we took 2 times 21 plus 3, that would give us 42 plus 3, which is 45 degrees. So we know that this angle is 45 degrees and this angle is also 45 degrees because it's an isosceles triangle. In our last and final example, it will be the same as before, but instead of having an expression, well, we have an expression, it's just smaller. There's no addition or subtraction. So this is an isosceles triangle. These are the base angles, therefore they're congruent, therefore this has to be 2x as well. So 40 plus 2x equals 180. 40 plus 4x equals 180. Subtract 40, and we have 4x equals 140 divided by 4. Therefore, x equals, 4 goes into 14 3 times with a remainder of 2, 35. So x is equal to 35, and the base angle is whatever 2 times 35 is, which is 70. So that is a 70-degree angle, and that is a 70-degree angle.